of two presentations. So Professor Kappos.
Okay, which is the most difficult, at least in my opinion, part of this exercise of the existing buildings? What exactly are you going to do with them? What exactly are you going to change in them to make them, well, satisfy the code criteria? So this is really a very tricky thing. And this is addressed, admittedly, to a very brief way in Clause 7, which is the design of the structural intervention, which actually comes after some sort of verification is not satisfied. So in this case, you will go to the design of your retrofitting. What are the key changes? Well, as I said, the scope has been extended to cover bridges. So this one is basically covering the retrofitting. This document is covering both the retrofitting of buildings and bridges. And after a very long discussion, which, by the way, is also briefly referred to in the background document, a very brief background document that I had drafted for this clause, it was deliberately left out to allow some flexibility. And the idea is that the code tells you how to verify your retrofitted or your upgraded building, but it only gives you some principles as to how you should structure or you should decide your interventions. Interesting and important change is that for the first time it is explicitly stated that you can do this upgrading of your structure by reducing the demand, right? So by using some sort of passive system, but it does not give you any detail of these systems, because these are given basically in parts 1 and particularly in part 1, 2 with more detail. It is clause 9 of part 1, 2, if I remember correctly. Still not properly covered is the case that all the seismic action is carried by a new lateral system. In this case, it is not allowed to do what many people are doing all over the world. This is something that we would like to emphasize. Many engineers, for simplicity, there's, oh yes, I have put a new lateral load system, so everything, all the lateral loads will be, basically the seismic load will be covered by this new system, which is not correct. You have to address only what happens to your existing structure, which is still there. So as a minimum, you should classify the existing structure as secondary element, and you should take it from there. Now, what are the criteria for structural intervention covered in 7.1, in clause 7.1? You should identified gross errors should be appropriately remedied. In highly irregular structures, structural regularity should be improved both in elevation and in plan. Of course, this is easier said than done. How can you do it? Well, can you improve it? You can improve this regularity by modification of the strength and the stiffness and all the stiffness of a number of the existing components, or indeed by the introduction of new structural elements. For example, in a building, you could add some structural walls and improve the regularity. Of course, this should be decided on an ad hoc basis, keeping in mind that you may or may not have the possibility to add these walls due to architectural functionality reasons. Increase in local ductility supply should be done where required to satisfy the verifications. Increase in strength due to the intervention should not reduce the available global ductility. So the two are interrelated here. And there is a specific note or a clause, subclause for major structures. Non-ductile lintels should be replaced. Inadequate connections between floor and walls should be improved. In my opinion, this is a very important requirement, or indeed, in this case, it is a recommendation. And out-of-plane horizontal thrust against walls should be eliminated. And as I said, there is an option. Instead of strengthening or upgrading, as it is called now, the existing structure, reducing the seismic action effects by introducing seismic isolation, typically with some sort of additional damping. What are the types of intervention, which, by the way, may be used in combination? local or overall modification of damaged or undamaged element, which may include just a repair if it is a slightly damaged element. Could be upgrading. Upgrading is the new terminology used for strengthening, in the sense that upgrading, for example, can also include the isolation and dissipation devices, which is not the case with strengthening, of course, or indeed full replacement, considering the stiffness, strength, and ductility, of course. Addition of new structural elements, for example, you may add braces, you may add steel, timber, or reinforced concrete belts in major reconstruction, or indeed you can upgrade your infill walls. Modification of the structural system, for example, you can eliminate some of the structural joints, you can widen and so on. So there are several options. You may add a new structural system to resist part of for the entire seismic action. I have already made my comment that by doing so or in doing so, you should not forget that you have an existing system, and you should check that this existing system will not collapse or will not be very heavily damaged while your new system is still in a pretty good stage. This is a very important aspect in my understanding. Possible transformation of the existing ancillary elements. The ancillary elements are what we called for many, many years the non-structural elements, but after a long discussion, now we call them the ancillary elements. That are, I mean, I'm sure that those of you who have attended the Part 1-2 seminar, you have heard about them. Addition of passive protection devices, dissipating bracing and base isolation, or indeed mass reduction or restriction of or change of use of the building, which of course is not really very good news for the owner of the building, as you may guess. And indeed partial demolition, which is even less good news to the owner. Okay, a few things about the ancillary elements. Repair or upgrading of ancillary element is also required whenever, in addition to functional requirements, the seismic behavior of these elements may endanger the life of the inhabitants or affect the value of integrity of goods stored in the building. I have really read this verbatim because it is a very carefully worded paragraph. In such case, of course, full or partial collapse of these elements should be avoided. How? By appropriate connection to the structural elements, increasing the resistance of ancillary elements, so basically making your, for example, major infills stronger, and taking measures of anchorage to prevent possible falling out of parts of these elements. Always the consequences of these measures should be taken into account, that they should be communicated to the owner. The justification of the intervention type, well, the documents relating should include the justification and should be, of course, made available to the owner. Now, the second and last part of this section, of this clause, is the retrofit design procedure. This one, of course, this is extremely critical. This includes basically 3 steps. All of them are important. The conceptual design, the analysis, and of course the verification. Conceptual design, first of all, it is strongly encouraged to use a preliminary analysis, which was also mentioned in a little bit more detail by Professor Frangin, because this can inform the selection of your retrofit scheme. Then the selection of the techniques and the materials, and the type of configuration of the intervention, very important part in the whole procedure. The preliminary estimation of the dimensions and the additional structural estimation of dimensions of the additional structural parts, for example, structural walls, and the preliminary estimation of the modified stiffness of the retrofitted elements. Then, of course, you have the analysis. The analysis was already covered by Professor Isakovic. It should, of course, account for the modified characteristics of the building, and the verifications, again, as per section 6.5 and also 5.5 that Professor Frangin presented. They should include both existing, modified, and new structural elements, and as a minimum, where, as I already mentioned in my first presentation, you should check limit state the near collapse. Information of the resistance of the existing. I mean, how do you carry all these things? You need specific provisions, depending on what material you are using, on the existing and on the retrofitted structural elements. What resistance does an element which has an FRP wrapping or, for example, a reinforced concrete jacket around it? So for this, you will go to the pertinent clauses. Most of this information is found in clause 8 in the reinforced concrete structures, and there is more limited information on the remainder of the chapters. Just to give you an idea, and not just leave it at the conceptual level, you can find, for example, information on the resistance of the retrofitted reinforced concrete structures in section 8.6. This, I understand, will be presented by Professor Chrysostomou later on. Of course, not all types of new materials are covered or new techniques. We are focusing basically on the ones on which we had sufficient state of the art. That we have sufficient, for example, testing data and so on. So we're covering reinforced concrete jackets, steel jackets, and FRP plating and wrapping. Okay, so these are the ones covered. They're giving the relations for strength, the stiffness, and of course for the available deformation capacity. Just as an example, for jacketing, which is arguably the most common type of strengthening, or if you prefer, upgrading with the new terminology of concrete columns, for example, but not only columns, also beams, even footings can be jacketed. There is the approach used is basically to modify the capacity, the resistance or the deformation capacity of an equivalent section which is of, let's say, a monolithically cast member. So these monolithicity factors, as many people call them, although it is not a term that has been adopted in Eurocode 8 Part 3, for example, and specifically the relationships adopted in the new Eurocode 8 Part 3 are of this form. The resistance of your the yield moment of your jacketed section is the resistance of the yield moment of an equivalent monolithic section multiplied by these factors. So for the first time in the literature, we're introducing monolithicity factors, which are not just dry numbers, 0.8, 0.9, and so on. They include some meaningful parameters, and the most meaningful parameters, as we found with Gina Thermo some time ago, is the axial loading, okay, which is defined as here. Okay, so this is basically the entire section. This is an interesting table that my colleague, Professor Dritsos, has compiled some time ago. It covers, strictly speaking, the current one, but most of the yes and no are applicable to the forthcoming, the new Eurocode 8. And as we mentioned in the background document, the BD means the background document, in applying the code, the engineer needs guidance, guidance additional to that given in clause 7. You can certainly not carry out your retrofit design just by using these relatively brief provisions that I have just presented. So what can you do? Well, I'm giving you some guidance. I'm not going to spend any time on it for the sake of time, but I have included an appendix which is much longer than my main presentation, which exactly presents these techniques for repair and for strengthening existing reinforced concrete members. It is based on a similar presentation, but much more detailed, that I have made in the Balkan Summer School a couple of years ago. So just to give you an idea of what is included, no comments at all. I'm presenting the local repair techniques. I'm presenting the strengthening of the tension zones through some jackets and so on, where, by the way, we're introducing some monolithicity factors, even some rigorous modeling of concrete interfaces, and of course, a lot of information regarding the FRP strengthening of our reinforced concrete members. So I will stop here, Ricardo, because I don't want to abuse our time, but please be advised that there is you can download in due course from the site this very detailed appendix, which hopefully will be useful when you are trying to design an intervention scheme. Thank you very much.
No, thank you. Thank you very much. Indeed, I don't know if any of you, either yourself or Professor Isakovic, want to follow up on the previous question that was posed to Professor Frankin on the guidance on material models to use, determination of parameters, discretization, and type of elements, or numerical algorithms and sensitivity analysis. So, because this was a question that was a bit left open.
Well, so probably I can answer. As I said, in Eurocode 811, Chapter 7, there are exact procedures how to define, for example, some ultimate rotation in concrete, let's say, how to define yield, how to define these properties for non-rectangular cross, compression zones. Everything is regulated there. And Chris is probably can say more about that, but everything is in chapter 7 of 1.1. It is displaced from Eurocode 8.3 because it can be used also for new buildings and bridges. So this is a common guidance, let's say, how to define the properties of these hysteretic loops that I showed in my presentation.
Okay. Yes, I do
just
agree.
a quick note, if I may. Just a quick note. Please pay particular attention to the appendices to some of the material related chapters. These appendices, as I mentioned very briefly, admittedly, are real encyclopedias of information, how you can even assume the properties of your old steel buildings. I presume Dimitris will expand on this. There are very nice tables depending on which epoch are we talking about, which period in time we're talking about, and giving guidance how you will assume or you will determine the properties of the steel structure. There is also abundance of information in Annex D for measuring structure. So yes, a lot of information that you need regarding your material properties in your that to use in your analysis. You can find them in these appendices. Thank you.